Okay, I'm going to show you now exponential growth doubling time problems. Okay, so let's consider a bacteria colony. And this bacteria colony has, I don't know, let's give it 1,000 bacterium. And if that's not the singular of bacterium, and this is not a realistic number for a bacteria colony, I apologize to any pedantic biologists. A bacteria colony has 1,000 bacterium. And it grows at a rate where it doubles. Every, let's say, 2 hours. How many will there be in 5 hours, 1 day, or 1 week? Okay, so we have 1,000 bacteria. The colony grows at a rate where the number of bacteria doubles every 2 hours. And I want to know how many there will be in 5 hours, 1 day, or 1 week. Okay, so I'm assuming you've already looked at compound interest. So you have a sense where you have an exponent representing the number of times you recalculate. And this we're going to recalculate every 2 hours. So I could easily say that the bacteria population is equal to 1,000 multiplied by 2 a bunch of times. How many times? Well, we multiply it by 2 every time we get a 2-hour period. So when we set this up, we just need that number to equal the number of 2-hour periods that have gone by. So for measuring time in hours, watch this trick carefully. I'm going to say that our population is 1,000 times 2, because we're doubling it, to the exponent of t over 2. Now, what does that mean? Let's consider it this way. We're dividing the amount of time in hours by 2. If 2 hours go by, 2 divided by 2 is 1. And that equation will make us multiply the population by 2, because 2 to the exponent 1 is 2. If 4 hours go by, 4 divided by 2 is 2, and we end up multiplying it by 2 twice. Is that understood? That's a very rhetorical question, I guess. I can't hear your answer there. Okay, so it grows at a rate where it doubles every 2 hours. I want my exponent to represent how many times it has doubled. I take my amount of time and divide it by what we call the doubling time. So let's try this for 5 hours. Question 1. Our population is 1,000 times 2 to the exponent 5 over 2. Because you see, when I take 5 divided by 2, I get 2.5. Our population has doubled 2.5 times after 5 hours. So our population is 1,000 times the 2 to the 5 over 2. So that's 2 to the exponent, and remember 5 over 2 is 2.5. 5.66. So our population after 5 hours is going to be 5,660. If there's any confusion there, let me try and draw it out. So let's look at hours, okay? So there's 1, 2, 3, 4, 5. And we start out with 1,000 bacteria. After 2 hours, it doubles. So after 2 hours, we've got 2,000. right? It doubles every 2 hours. So after 2 more hours, it doubles again, bringing us to 4,000. So we double it again. After 6 hours, it'll have doubled again up to 8,000. And we're trying to figure out somewhere in the middle. Now, you can't go halfway between 4,000 and 8,000 and get the right answer because this is not linear, it's curved. So it goes up to 5,660. And we figure that out here. Notice that t over 2, when t is equal to 2, it gives us times 2, giving us the correct 2,000. When t is a 4, it gives us times 2 and then times 2, because 4 over 2 is 2. So we end up with 2 squared. So we go from 2,000 to 4,000. But this is going to give us the right answer everywhere in the middle as well. Okay, so let me answer the question now. I'll do it a little quicker for 1 day and for 1 week. So after 1 day is 24 hours. So we have a population now of 1,000 times 2 to the 24 over 2. Because remember, in 24 hours, you have 12 2-hour blocks. Imagine your favorite movie is 2 hours. You could watch it 12 times in 24 hours. So I have 1,000 times 2 to the exponent 12 gives us 4096. 1, 2, 3. So that gives us 4,096,000. Now let's look at 1 week. In 1 week, we will have 24 times 7 hours. 168 hours. So our population will be 1,000 times 2 to the 168 divided by 2. Or 1,000 times 2 to the 84. Now I can't guarantee this calculator will handle that. Let's give it a try. 2 to the 84. Yep, it's got it. It's in scientific notation, so look closely here. Your calculator will probably do the same thing. That means we have 1.9 times 10 to the exponent 25. This particular calculator does not show us the times 10 to the exponent. Yours may or may not. And now remember, that has to be multiplied by 1,000. You're not going to see a big difference, except you'll see that exponent change to 28. So the way I interpret that, this is 1.9 times 10 to the 28. Looks like a small number, but actually, let me draw this out to make it clear, remind you scientific notation. So what that means is the decimal gets moved over 28 times. So I've moved it over once. There we go. That's how many bacteria there'd be after a week. Now, to be realistic, that's not what actually happens. The bacteria will grow exponentially up to a point until it reaches what you call the carrying capacity of the environment in which it lives, and then it plateaus.